Talk a bit about it. Right. Hi, my name is Baron Monikos. I still am a construction manager for Contract 310, which involved the tunnels that come from Plumstead in that direction up to what we call Woolwich Box, which is this hole in the ground here, and then go on that way into the Thames through to North Woolwich. And so it's about a mile of tunnelling in that direction, about a mile of tunnelling in that direction. And this was a sort of dog bone shaped box, just a hole in the ground. And we also built the platforms. So this is the sort of raw structure, just in concrete, no appreciation of anything architectural or pretty. I understand that the sort of columns that run through the middle are going to be clad in bronze to represent the sort of cannons that have been made traditionally at Woolwich Arsenal. So some other clever people will come in and make it look really gorgeous, I'm sure. These things hanging down for the platform screen doors, so it's going to be like the more modern stations on the underground with the screen doors too. They're part safety feature and part for ventilation. They save an awful lot of money, especially in winter where you try and keep the heat in, and in summer where you try and keep the heat out. If you have air conditioning and a train coming through, they have 16 trains per hour. That's like a bicycle pump pushing all the very expensive air conditioned air right out of the station. So the platform screen doors keep it in the station. So when they introduced them in Hong Kong, the MTR, there's so much money spent on air conditioning. They paid for themselves in 5 years, just on electric bills. So they're a good idea. We like them. It's 220 metres long as a platform. The box is 258 metres long. And so when our 1,000-ton tunnelling machine got to that end and broke through, we then had to drag it on rails with some very sophisticated pistons and put its nose up against that wall and start again and relaunch it. In the corner is a little figurine, that's Santa Barbara, because we have European tunnellers. All tunnellers, all underground workers are very superstitious. So I'm a Cornish tin miner by trade, once upon a time, until they closed them all, and then I had to get into tunnel. £26 a shift, I was happy as Larry. If they hadn't closed the mine, I'd still be there, pole dart. That's right, me and pole dart, we're like that. But, see me in this song. Anyway, no, all underground workers are superstitious. So where I'm from, no singing underground, no whistling. You eat the pasty shaped like a pasty because you can't touch anything you eat. And that's superstition, but the real reason is there's arsenic in the water. It's a cumulative poison. So the superstition has a basis in fact. So the bit you touch is the bit you throw away for the ghosts, the Tommyknockers. Right? Anyway, we have European tunnellers, we have German and Irish consortium that did the tunnelling for us. So they believe in Santa Barbara. She's the patron saint of people likely to die suddenly. So tunnellers, explosive manufacturers, and sort of deep sea fishermen as well. That's what PK is for. So it's very common to see that in European tunnels. And as I say, this big station box, I'm all about underground things. It's what I've done for 32 years. No, I don't look that old, do I? But so to me, that's the main event. This is all just landscaping to facilitate my stuff. So we'll get to work.
Santa Barbara.
That small tunnel will leak more than our big tunnel, where the quality is. But I mean, all people today.
Well, of course, the British
Hey, so this is a Crossrail Tunnel, one of them, and from your pamphlets and everything, it goes from, I can't remember now, Paddington, the tunnelling bit goes from Paddington through to Limo, touches on the Crossrail Tunnel, which is we sort of recycled the tunnel. It's a Victorian tunnel that we hollowed out and made a bit wider for our trains to go through. But essentially they're all the same. There's 8 segments in a ring. A ring or a hoop is a very, very strong structure once you get it all in place. So, and essentially the way the big tunnelling machine works is the front, they're 110 metres long. The first 10 metres is all about digging. And as that is all full of sort of rams and hydraulic motors. And the face turns and chews out a bit of chalk. And it chews out about 1.6 metre long piece of chalk. And at the back end of that, as we push it forward off the last ring we built, it leaves a 1.6 metre gap. And we build one of these rings in. So the rest of the 110 metres of the machine is like a factory. It's just servicing the bit at the front, servicing the gap. So it allows trains in. It's got transformers, and it's got a mess for the guys to eat, a little canteen for them to eat. Inside the tunneling machine. That's why it's so long. It's got hydraulics and electrics, and it's got a refuge. If there's a fire, they can go and sit in the refuge like a container. They can sit in the refuge for 24 hours to be rescued, which they'd be rescued way before then. We spend hundreds of thousands of pounds making sure the machine can't burn, because that's the thing we fear the most. Because you're in a dead end and you're blowing air in for everything to be cooled down and breathe. So nothing feeds a fire more than a nice draft there. So all the oils on the machine are non-flammable, the cable coverings can't burn. The biggest threat is people bringing their sandwich wrappers and throwing them under things instead of taking them out properly. So you have to educate the guys for their own safety. But as I say, there's 8 segments in a ring. They have this is the last one to go in, this is called the key. So that's a wedge-shaped thing. All of these, as the gap appears, we bring them in from the back, pick them up with a vacuum pad on something called an erector. The erector can go through 360 degrees and place them anywhere in the circle. Plonks them in there, and then the rams come on from the back of the cutter head, press them into place, and hold it while we bring the next one in. Once we've got the key in, it's like the arch of a bridge. It's very, very, very strong. It's much stronger than the chalk we dug out to put it in there. And it's self-supporting. Because it wants to rest in on itself, and concrete's very strong in compression. It's very hard to crush. At that point, it becomes very, very strong and stable. There's a little gap around the outside, because obviously the hole we dig has to be bigger than the ring we put in it. And that we fill with grout. We pump grout around it, which is just cement without stone in. And that, if we do that very quickly, then the ground above us doesn't have time to react and start moving in on that gap. And there's no settlement. We don't disturb the ancient buildings above us. So the essence of this is quick support. We get it in and then fill the gap quickly and get on and do the other one. Dig another 1.6 metres, move forward, create a gap. Okay. Do it 3,406 times. And then we're finished. See? I would thoroughly recommend this tunnel engineering to any teenagers that are just doing their A-levels, right? It's so easy. It's just big boys Lego. All the design stuff's done already. You just turn up and bolt it all together. Right? And it pays more than civil engineers, and it takes you all around the world. There's just nothing to know.
Pieces built in that way as well. Yeah?
There's dowels, right? There's everything's done in sets of 22. Don't ask me why. I don't know why. On the back of the machine, there's 22 rams. There's 22 positions we can put the ring all the way around. And there's 22 dowels that go between, and they're very thick, rigid, and they've got serrations on. So when a plate is pushed against the last ring, you can hear it go click, click, click. And at that point, it would actually stand up on its own. I wouldn't like to try it because they weigh 3.5 tons each, but they do. And when occasionally we mucked it up and got them in the wrong order, and we couldn't pull them apart, we had to break them out and smash up the concrete to get the nylon down. So very strong, very rigid, all linked together. And as you can see, beautiful to the eye. So a good quality tunnel is a very smooth thing. If you were able to look down the Channel Tunnel, which we built 23 years ago, there's lots of lips and steps and bumps and things because we weren't as good as we are now. The other thing to say is, how do we turn corners? The key is not as long as the fat bit opposite. It's a tapered ring, so this bit is 30 mil shorter than that bit. So when we want to turn a corner, We wanted to go right there. We put all the keys on the right-hand side and left the fat bits on the left-hand side, and that allowed us to follow where the tunneling machine had been. And the tunnel lining then went around behind us. Yeah. As I said, nothing hard at all.
But how do you direct it to go in?
It can only go where it's been done.
No, sorry, I mean
The tunneling machine, that's all done with lasers and surveying. We learned something at the Channel Tunnel that a laser is not a straight line, it follows the curvature of the Earth. And that took about 800 metres to work out. We were going slowly wrong and wrong. And then we discovered that was the reason.